Hello everyone. Today we are going to learn about the weather resistance of rocks. What is the weather resistance? As we know, roads and bridges are uncovered buildings exposed to nature. They are often affected by various natural factors, such as temperature fluctuations. The internal structures of rocks are damaged because of thermal stress. Also, in a humid environment, they are damaged by alternating freezing-thawing of positive and negative temperatures. Therefore, the resistance of rocks used in road and bridge construction to natural factors is called weather resistance. The weather resistance is characterized by two indexes, that is, frost resistance and sturdiness. Firstly, the frost resistance refers to the mass loss percentage of rocks after 25 or 15 freeze-thaw cycles. Secondly, the sturdiness refers to the mass loss percentage after 5 sodium sulfate solution erosion tests. Students should notice that the solution used in the frost resistance test is water, and the solution used in the sturdiness test is sodium sulfate. Next, let's look at the two characterization indexes of frost resistance: mass loss percentage and freezing-thawing coefficient. How to reflect the frost resistance? The first is the mass loss percentage, that is, the mass loss of rocks after freeze-thaw cycles. We know that rocks have many tiny pores. When rocks are naturally saturated with water, most of their open pores connected to the outside are filled with water. When the temperature drops below zero, the water turns into ice and increases in volume, thus exerting tensile stress around the bore wall. After several freeze-thaw cycles, rocks will witness cracks, missing edges, unfilled corners, or surface looseness, resulting in mass reduction. Therefore, the mass loss percentage is obtained by dividing the mass loss after freeze-thaw cycles by the drying mass before freeze-thaw tests. Secondly, the freezing-thawing coefficient, Kf for short, is obtained by dividing the saturated compressive strength of rocks after several freeze-thaw cycles by the saturated compressive strength without freeze-thaw cycles. The rocks will be damaged after freeze-thaw cycles, and the strength before and after freezing and thawing will be different. Therefore, the frost resistance can also be reflected through the freezing-thawing coefficient. When the freezing-thawing coefficient is greater than 75% and the mass loss percentage is less than 2%, the frost resistance is great. Students can remember these two data indexes. Okay, everyone. Next, we have a simpler and quicker evaluation method of rock weather resistance: sturdiness test. As I explained earlier, the liquids used in the sturdiness and frost resistance test are different. The saturated solution of sodium sulfate is used for the sturdiness test, and its working principle is similar to that of water. When the sodium sulfate solution is immersed in the pores of rocks and dried, its volume will expand because of the crystallization. It produces an effect similar to that of water freezing, which makes the peripheral wall of rock pores subject to tensile stress and causes damage to rocks. Then, a simple and quick method to evaluate the weather resistance is through the mass loss percentage of rocks. That is, the mass loss percentage of rocks equals the mass loss after the sturdiness test of rocks divided by the drying quality of rocks before the sturdiness test. After learning the above contents and combining them with the water absorption, let's think about which index is used to evaluate frost resistance. There are three indexes characterizing frost resistance. Firstly, the change of strength after freezing and thawing is expressed by the freezing-thawing coefficient, that is, the post-freezing strength divided by the pre-freezing strength. Secondly, it is reflected by mass loss, and the index has a percentage of mass loss equal to the mass difference of rocks before and after drying, divided by the mass before drying. Thirdly, it is represented by the water absorption capacity of rocks, such as the saturation coefficient equal to the water absorption at normal temperature and pressure divided by the water absorption in vacuum state. Dear students, the frost resistance of rocks is an important part of our engineering inspection projects. China has a vast territory. In northern China, because the temperature in winter is below 0 degrees Celsius, we should test the frost resistance of engineering materials for projects. As a project quality inspection engineer, we must learn to take different testing indexes according to different environments. That's all for this lesson. Thank you.